Rational exponents. Okay, here's some things to remember. When simplifying the denominators, okay, I'm looking at the denominator I have right here. When I'm simplifying this, I want to make sure the inside exponent, which is my 2, okay, I want that to match the outside radical, or I should say the outside root. That would be even better. It should match this number here. How come? Because if I have this, and you don't have to write this down, we'll eventually get here. If I have this, my exponent of 5 and fifth root will cancel, and the radical goes away. So that's ultimately what I want to try and do for this fraction. But some people say, you know what, listen, instead of dealing with radicals, I like to have a rational exponent, meaning I like to have my fraction as an exponent. Meaning if I was to convert this to have a rational exponent, and you don't have to write this down, I will do it both ways. What would be my rational or my fraction exponent? 2/5. And then that I want to make equal to 1. That 2/5, I want to somehow make that x to the 1 instead of 2/5. All right? So I'm going to show you both ways here. All right? Here's the first way. I like dealing more with the radicals when I can. It doesn't mean you always have to. Sometimes it's better to deal with fractions depending on the problem they give you. But this right here, I like the radicals. So I'm going to multiply this by something. Okay? And when I'm done, I want to have the fifth root of x to the 5th. All right? So in order to multiply something under the radical by another radical, and they get both put into one radical, follow me here. I'm going to put something here. What does this root have to be for this here? What does the root for this radical I just drew, what does that need to be, this root on the outside here? 5. I pointed to you. There's no said it. He just repeated it, and I was looking right at you. So look at it. I can combine radicals, right? If I say radical 5 times radical 7, I can combine those. That's radical 35. If this was a square root, this was a cube root, I could not combine them. I mean, I could change them, but we're not going to get this. This is what I'm talking. I want these to be the same. Okay, so they are. All right. Now, x. What's going to be the power that's attached to my x underneath that fifth root? 3. How come it should be 3? Yes, when I multiply things together, don't I add the exponents? Isn't 2 plus 3 5? So guess what's going to happen? This fifth root is going to cancel this power of 5, and I have an x. But the golden rule tells me what I do to the bottom of a fraction, I also have to do down. So I'm going to multiply this by the exact same thing. And this will carry here. And that will be in your answer. And that's how you do this using radicals. I don't think it's that difficult. The difficult part, the most difficult part of this process, which I don't think is difficult at all, you got to remember the root's got to be the same. And what exponent goes here? What am I adding? The original exponent, so it matches the root. Yeah, right? Okay. Now, let me show you, for those of you who are like, well, this is showing the fraction way. Let me show you the fraction way. I'm going to turn that denominator into a rational exponent. You guys told me that was 2/5, correct? Yeah. I'm still going to multiply that by something so that I end up with just an x in the bottom. Or, what was the exponent? What would the exponent be for this last x here? The exponent is 1, right? So, I multiply this by x to what power so that it's 1? 3 bits. Because don't I add exponents when I multiply? 2/5 plus 3/5 is 5 bits. And 5 bits is equal to 1. right? What do I do to the bottom? You have to do to the top. So now I got x to the 3/5. And oh my God, this is the same as here because the bottom is both an x. And is it x to the 3/5 for my numerator equal to bottoms out? The numerator and my other fraction here.
Wait, so for a part that you see to the bottom, which one are you doing that for? Like which fraction?
When I multiply here, whatever I put in the numerator to multiply this by, I also have to put in the numerator. Did I say numerator twice? Whatever I put in the denominator here and multiply them, I have to put in the numerator. Think of it this way. Think of it this way. If I have 1/2 and I multiply the bottom by 4, I can't leave the top. That's still not 1/2. Don't I got to multiply the top by 4 to keep it to 1/2? It's the same rules. It's the same rules. Bam. So, my children, any questions with this?
Not at all, sir.
The fraction way seemed a little bit easier because it seemed like less writing, so you're not going to keep it drawing the radical. But I like the radical better, and you'll see that sometimes it works out nice. Sorry. Math makes me hungry too. And I'm always thinking math, that's my problem. So. All right. Rational exponents, things to remember. Rules for dividing. Fractions. And multiplying radicals and all that jazz. Now, who can tell me if I have a square root with a fraction underneath it, we'll call it a over b. What is that equal to? It's radical A over radical B. I just break that radical top, radical bottom. Unless, I mean, I would always do that. Unless, for some reason, I could simplify this fraction here first. It would make my life easier. So if I have the square root of AB over B, I mean, I could say radical AB over radical B. I could do that, but why wouldn't I just do this first, cross all my B's, and just call it radical A? If you can simplify underneath, thank you. If you can simplify underneath the radical first, the fraction, go ahead and do it. So let's take a look at example 2. Example 2, okay, is there, what makes this good for us, ultimately in the end? Okay, first of all, we can cancel x's. I can take 2 of these x's and take 2 of these x's, and that becomes a 6. Okay? Now I've got there's nothing else I can cancel or reduce. So I'm going to break this radical top, radical bottom. Careful, it's cube root. So I'm going to say cubed root of 3x to the 6th y squared all over the cubed root of 8. Now, why am I not going to worry about multiplying the cubed root of 8 by something to get rid of that radical? Because, Jasmine, yeah, the cubed root of 8 is 2. That simplifies for us right off the bat. This is equal to 2 over the cubed root of 3x to the 6th y squared. Now, let's just clean up the top, shall we? Is there anything we can do? Can we take the cubed root of 3? Can I reduce that? No, there's no perfect cube that goes into 3. So I'm going to end up with the cubed root of, there's still going to be a 3 in there. What about x to the 6th? What does that simplify out to be? X squared. Is there a remainder? Is anything going to remain under that radical? No. So 2 x's come out, x squared. What about the y squared? Does 3 go into 2 at all?
Oh, no.
No. It goes into 0 time and you still have 2 remaining under the radical. I know. That's why. You know how I look at this? Do you guys remember? I don't know how you were taught this. So let's say I divide 5 into 25. Can you say 5 divided by 25? Do long division. So let's take a look at this right here. Let's do the cubed root of y squared. Look what happens when I do this. It's 3 divided by 2.
Oh,
Yeah, see that? Use that. Love it. Embrace it. Share it. But always give me credit. Okay? So if you're confused as to what happens there, it's now you know. And no one's at the back. Right. All right, let's do another one here. We're not going to worry about this negative exponent now. We can have a negative exponent. For this problem, I don't care. The negative exponent, just leave it there. We're going to take the square root of this. Okay, remember, there's a square root, there's a 2 on the outside here. Okay? How do we do this? Jordan. No, wait. Split it up. So what do you think the square root of first? What's the square root of 9? What are you going to think the square root of next? X to the negative 6. And what will that give? Yeah, what is negative 6 divided by 2? Negative 3. Don't be bashful. And what about that y to the 4th? So I just put a 2 here? It's y squared. There you go. Look how easy that is when you can just go down the line. Just have the answer. All right? The line to have the answer, buddy. All right. I mean, nothing crazy, right? Yeah. So nothing crazy yet. Now, we're going to take the same exact problem. And I want to do one thing to it. Now I want to deal with that negative exponent. Because when they say to simplify something, that means simplification requires no exponent to be negative. It should all be positive. So, what do I do with negative exponents? I flip them. I flip them. So, I could do this one of 2 ways. Didn't we just say our answer to this problem right here? Oh, wow. I know I'm lazy. Didn't we say the answer was this? We just did this problem. How? This is technically a fraction over 1. Every individual number is technically a fraction over 1. We don't write 1. If the exponent is 1, we don't write it. If the coefficient is 1, we really don't write that, okay? If it's over 1, we really don't write it. So this expression I just wrote on the board is the exact same as this one. All right? So now we flip negative exponents. So what happens here?
oh, you gotta flip the whole thing?
Now the whole thing, I flip what? Whatever has a negative exponent flips. What's the only item on top? Yeah, it's my x. That's the only thing I flip. So now the 3 and the y squared stay on top, and x will turn to a positive 3 on the bottom. There you go. That's it. Now, I could have created a fraction because we knew the answer to this, and this probably would have been the easier way to go. You know, get your 3x to the negative 3 and y squared first and flip it. But some people will look at this and they want to deal with this negative 6 first, and they'll say this is the square root of 9y to the 4th over x to the 6th. Which you do radical top over radical bottom, which would still give me 3y squared over x cubed. You get the same answer. There are multiple ways to get to the same answer. There are not multiple answers, unless there's something quadratic on this too. But you know. All right, so you could have done it this way. Don't feel like, oh, don't say, I want to flip this first, but I can't because Visca did it. No, you can. That's fine. You can absolutely do that. Okay, so let's start with something easy. I'm going to give you guys about a minute to simplify this one.
Nobody told me.
All right.
To work.
You ready? There you go. Hey, Jasmine is in tears talking about her dad's hat. That's fantastic. All right, let's talk about number 1 here. So what am I going to multiply the numerator by, or excuse me, the denominator by? What has got to be the power to that? It's got to be the fourth root of y to the third. The roots have to be the same, okay? And they are. That way, the root stays the same.
Oh, so
right?
where are you getting that from?
Because I want my y to have a fourth power. And when I multiply things together, don't I add exponents? 3 plus 1 gives me my 4. So guess what happens? Bang, bang, and I end up with a y on the bottom. When I do to the bottom, I need to do to the top. So I multiply this times the fourth root of y cubed. And Jasmine, do you know? No? Okay, so let's go through this with a logical step here. If I multiply 2 times y, Jasmine, what do I get? This is all separate. I get 2y, Jasmine. If I multiply 2 times radical y, what do I get, Jasmine? 2 radical y. If I multiply 2 times the fourth root of y, what do I get, Jasmine? That's all it is.
That's it.
Yes. So therefore, when I multiply these two together, I get 2 times the fourth root of y cubed, which is 2 fourth root of y cubed. That's your answer. Now, I just want to show you one thing. How come that root right here needs to be the same? Think about if I were to make those fraction exponents. When I add or subtract fractions, what has to be the same? The denominator. Isn't this the denominator at the bottom of the fractions? Yeah, does that not make sense? So if I were to go to here, where was it? On the very first slide here, doesn't this have to match this in order to add them? Well, the denominator is here. It's bottoms out, isn't it? They have to be the same. That's why they'll stay the same. Because when you add our fractions, the denominator stays the same. When you add our fractions, that stays the same. You gonna put your book in there? All right. So let's go here. I think I want to do one more with you. And what's that? Yeah. This one right here. So the answer is this. This was just an example I was talking with Jasmine about. Okay? There you go. All right? Yeah, the denominator, if you're simplifying it, you need to get the radical out of the denominator. So the denominator should not have a radical. Yes. Yeah, your numerator can have a radical. All right? So, last one, and then we're going to let you guys loose on the remainder. Actually, no, we're going to do the remainder of them for classwork tomorrow. So there is no homework tonight. Yeah, you're welcome, because that was a funny story today. Anyways, can I simplify, Jalen, does it look like I can simplify that 8 cubed over b squared? Is there anything I can cancel in that fraction? No. Go. He's packing. He's going to Tennessee. I don't know where that kid's going. All right. I cannot cancel this A or B, so I'm immediately going to radical top, radical bottom. Be careful. That is a fifth root. So I got to do fifth root top, fifth root bottom. A cubed in the numerator, b squared in the denominator. Squat. Now, I want to make sure the bottom radical goes away, which means I need to multiply the bottom by something with a radical. What is the root of this radical going to be? 5, because they should match. Those are the denominators. Now, a lot of people, when I say a lot of people, some people, when I say some people, I mean some people. Don't don't even look at this for right now. Just focus with this. I want this to be the fifth root of b to the fifth power, don't I? In that case, the fifth root will cancel with this, and I'll end up with a b in the bottom. So what am I going to put under this radical? Here. So when I multiply the bottoms, I get b cubed, because my 3 plus my 2 gives me my 5. What I do to the bottom, I have to do to the top. So we'll apply this times the fifth root of b cubed. Better off in Tennessee, but all right, now I can look at this. Now I can do that. Get rid of that. What do I get? What happens when I multiply the fifth root of a cubed times the fifth root of b cubed?
AB cubed.
Okay, I get a cubed, b cubed. Can I put them under the same radical?
Yes.
Yes, because they both have the same root. So I can put them all under the fifth root, and it's a cubed, b cubed. That's it. I mean, if you wanted to change these to fractions, I could make this top a to 3/5 times this top, which is b to 3/5. If I multiply them together, I just get a to the 3/5, b to the 3/5. These are the same denominator, so bottoms out, it's the same one. See what I'm saying? You can do that, but I would much rather just do the radical. So we are not going to have any homework tonight, but the remainder, you bring this back tomorrow, and we're going to do it for classwork and go over it in class tomorrow.